Welcome to Ganesh Institute channel, collaborated with Fuel Up Academy. So today we are going to discuss about linear transformation. In our last video we had discussed that how we can change a matrix into its diagonal form, right? Diagonalization of a matrix. In today's video we will discuss about canonical form of a matrix. How? Let me give you an example. Here you are given with a quadratic equation with three variables x, y, z. What are quadratic equations, by the way? Having degree 2. Highest power of the variable is 2. You can see the power is 2. Now you have to reduce this into canonical form. Let me tell you what is canonical form. Canonical form is any form which can be expressed as the sum of the squares of variables, like x square plus y square plus z square. This is a canonical form. Okay, so you have to reduce it into a canonical form and you have to specify the matrix of transformation. Means you have to find out the orthogonal part of the matrix, or you can say congruent part of the matrix. Alright, let us start. So here, first of all, let me give you a general scenario. Whenever you are given with an equation of the form like this, where ax square plus by square plus cz square, 2bc, 2ca and 2ab. Okay, this is your equation and you have to convert it, transform it into a matrix form. How can you do so? So, in matrix form, you will write it like, first of all, the highest power coefficient in diagonal form, okay, A, B, C. Then you have to take firstly BC, the part of BC, and take half of the coefficient. So half of the coefficient is 1 and put it here in two places, 1, 1, okay. Then half of the coefficient of CA, so half of 2 is 1, 1 here, and half of the coefficient of AB, 1, 1 here. So this is your matrix form of this quadratic equation, alright? Now, whenever you want to transform it into a canonical form, you have to find out the eigenvalues of this matrix. So let's say lambda 1, lambda 2, lambda 3 are your eigenvalues. Then the canonical form will be lambda 1 x square, lambda 2 y square, lambda 3 z square equals 0. Got it? Thereafter, for matrix transformation, what you can do, you can find out the model form of the matrix with the normalized form of eigenvectors. What does it mean? So let's say you know how to find out eigenvectors. We discussed it in our last videos. So once you will find out the values of eigenvectors, let's say when you put lambda 1 in the characteristic equation, your eigenvectors are x1, y1, z1, then x2, y2, z2 and x3, y3, z3. If you make the matrix of these three set, then it will be your model form. Okay, so this will be x1, y1, z1. This form will be, and once you will find this form, this model form, you have to find out the normalized vector form. So normalized means taking the value of eigenvector and divide it with the square root of the eigenvector, sum of the squares of eigenvectors. Okay, so normalized form for x1, normalized form for y1, y1 x1, y1 z1, x1 y1 z1, and for z1 again same. Okay, so let's do this question. You are given with a quadratic equation. So the matrix form for this is, first of all, the coefficient of highest power in diagonal form, right? Then half of yz part, half of minus 2 is minus 1 here. Half of zx part, half of 2 is 1 and half of minus 2 is minus 1, right? Half of this part is minus 1. So this is your matrix. Now you know how to find out eigenvalues, right? Make a characteristic equation. So you can check out last videos if you don't know how to find out characteristic equation. However, I am explaining it here as well. This should be 0. So a minus lambda I means 3 minus lambda, 5 minus lambda, 3 minus lambda, rest all should be same. Right? Why? Because A minus I form identity matrix of 3 by 3 order. So 1, 1, 1 and rest all are zeros. So you just deducted minus lambda from here. Okay. Now find out the values. 3 minus lambda, you know how to find out determinants, right? Hide these two. What is left? 5 minus this multiply this. So if you multiply these, 5 3s are 15 minus 5 lambda minus 3 lambda minus minus plus lambda square. Minus is in formula and when you multiply these two it will be plus 1, right? Then minus is in the formula, second part. If you hide these two, multiply these, minus 3 plus lambda minus 1 which will be plus 1. Then take third part. If you hide these two, 1 minus 5 minus minus plus lambda, right? So the value will be minus 8, 15 minus 1, 14, minus 2 plus lambda, minus 4 plus lambda. Okay? So this will be minus 24 and then let's take it here. Let me grab just a so if we take the value there, let me write the original form. 3 minus lambda, lambda square minus 8 lambda plus 14, minus minus plus. Okay, this is your form. If you multiply 3 with this, 3 lambda square minus 24 lambda plus 42, 14 times 3, minus lambda cube minus minus plus 8 lambda square minus 14 lambda. Alright, now arrange it in decreasing order of their powers. Minus lambda cube. Now this is 3 and 8, 11. Then this is minus 24, minus 14. What is it? Minus 38. Right? And then plus 2. So minus 36. Then 42. Minus 6, 36. So now hit and trial. How you can find out hit and trial which number will be the best? So you can take the factors of this 36, which is 2, 18. So if you put 2 in place of lambda, you will find out minus 2 cube, 2 times 2 is 4, 4 times 11, 44, minus 36 times 2 is 72, plus 36. So minus 8 plus 44 minus 8, is it correct? This is 36 times 2, 72, 2 times 2 is 44, 36, right? Minus 8 plus 44, this is 12 minus 6 is 6, and 6 minus 3 is 3. So 36 minus 36 is 0. Correct? So that means lambda is equals to 2 is your factor. That means lambda is equals to 2 is your root. So lambda minus 2 is the factor. Once you find out about the root and factor as well, then divide it with it. So minus lambda square minus minus plus 2 lambda square 11 minus 2, 9. So 9 lambda square minus 18 minus 18, right? Minus, to make it minus 18 lambda, you need 18. So minus 18 minus plus 36. This is cancelled. So your equation is lambda minus 2 multiply minus lambda square plus 9 lambda minus 18, right? Let me erase this part. So these are your factors. Lambda minus 2, you can take minus common. Lambda square minus 9 lambda plus 18. Now you know how to find out the values. 18, split 18 in the form of addition and subtraction of 9. What it can be? 6 and 3. 6 times 3 is 18 and 6 and 3 is 9. So 6 lambda minus 3 lambda. If you take common lambda, what is left? Lambda minus 6, lambda minus 6, minus lambda minus 2, lambda minus 6, lambda minus 3. If you put them as 0, so lambda will be 2, 6 and 3, right? 2, 6 and 3, or you can say 2, 3 and 6 if you arrange them in increasing order, right? So this will be your lambda 1, this will be your lambda 2, this will be your lambda 3. So as I told you in the beginning of this video, that canonical form will be lambda 1 x square, lambda 2 y square, lambda 3 z square. Okay? This is our first part. Now we have to transform it into the matrix of transformation. So how we can do so? For that we will require, so let me write it here. These are your eigenvalues. Now you have to find out eigenvectors. How can we do so? You know how. Let me remind you. You have to first of all you have to take a minus lambda I and x form, okay, equals 0. So one by one put all of these lambda values. So if you put lambda as 2, so a minus lambda, put here 2. 3 minus 2 is 1, minus 1 minus 1, sorry 1, minus 1, 5 minus 2 is 3, 1, minus 1, 3 minus 2 is 1. This is your a minus lambda I, and x will be in the form of x, y, z. You can take it as x1, y1, z1. Okay? Now you know this is 3 by 3 matrix, 3 rows, 3 columns, and this is 3 by 1. So the answer, the resultant matrix will be 3 by 1 order. So multiply it with this. First row, first column, all the elements will be, let's do it like this. So x1 minus y1 plus z1 equals 0, minus x1 plus 3y1 minus z1 equals 0, x1 minus y1 plus z1 equals 0, right? If you think that I did it so fast, so you can check out other videos related to eigenvalues where I explained you that how we can do it, okay, in a slow motion. So let's find out the eigenvectors for this. If you take these two equations and add them, this will be cancelled, right? And 3 minus 1 will be 2y1, z1 is cancelled, so y1 is 0. If you put y1 here, what you will get, or here, y1 0, x1 will be minus z1, or you can say z1 will be minus x1, right? z1 will be minus x1. So your x1, y1, z1 eigenvectors are, coefficient in front of y1 is 0, x1 is minus 1, or you can take it 1, and z1 is minus 1. far doesn't matter, right? So your first set, it is this. So your first set of eigenvector is 1, 0, minus 1. Okay, now let us find out rest 2. So for rest 2, what you have to put? Second value, which is 3, right? So if you put lambda as 3, what you will get? 3. 3 minus 3 is 0. Rest is same, minus 1. 5 minus 3 is 2. 1 minus 1. Hold on, please. Okay. Minus 1. 5 minus 3 is 2. And 1 minus 1. 3 minus 3 is 0. Right? Okay. Now if you multiply this will be 0. Minus y1 plus z1. This will be minus x1. 2y1 minus z1. This will be x1 minus y1. And z1 will not be there. Okay. You can again add them. What you will be left with, 2 minus 1 is y1. And z1, when it will go into the right hand side, it will be y1 equals z1. Okay. And if you put y1 as z1 here, in any of the equation, like, see, if you put y1 as z1, so here, y1 as z1, so x1 will be y1, or you can say x1 will be z1, right? So, your 3 these are x2, y2, z2, right? Because this is second eigenvector. So, all the variables are in the form of 2. Okay. So, your x2, y2, z2 will be the coefficient of opposite of x2 is y1 and coefficient of y1 is 1. Coefficient in opposite of y2 is 1, 1. So, your second eigenvector is 1, 1, 1. Okay. Now, third point, if you put 6 in place of lambda, what you will get? 3 minus 6 is minus 3. 5 minus 6 is minus 1. 3 minus 6 is minus 3. Right? This is your matrix. Then you can take x as x3, y3, z3 because this is your third part. Then if you multiply this, minus 3x3 minus y3 plus z3 equals 0. Minus x3 minus y3 minus z3 equals 0, and x3 minus y3 minus 3z3 equals 0, right? Now solve these three equations. What you will get? If you add these, x3 will be cancelled, minus minus plus, minus 2y3 is minus 4z3. If you take 2 as common, minus 2 as common, so y3 plus 2z3 is equals to 0. Y3 will be minus 2z3, okay? And if you put y3 as minus 2z3 in any of the equation, it will be minus 3x3, minus minus plus, this will be 2z3, 2 and 1, 3z3, so x3 will be z3. So what are your eigenvectors? In front of x3, your coefficient is plus 1. Here, in front of y3, it is y minus 2 and z3 is plus 1. Okay. So, your eigenvectors are 1, minus 2, 1. Okay. Now, these are your three vectors. So, your matrix of transformation will be just the matrix from x1, x2, x3. See, this is your x1, y1, z1. So put it here. But before that, you have to convert it in normalized form as well. As I told you, normalized form is you have to find out the square root of squares, sum of squares of these three. 1 square, 0 square, minus 1 square. What it is? 1 plus 1 root 2. This will be 1 square plus 1 square plus 1 square, which will be root 3. And the sum of the squares of these eigenvectors. 1 square is 1, 2 square is 4, 1 root 6. Okay? So these are your three normalized form. So normalized form will be 1 upon root 2, 0 upon root 2, minus 1 upon root 2. Then 1 upon root 3, 1 upon root 3, 1 upon root 3. And 1 upon root 6, minus 2 upon root 6, 1 upon root 6. This will be your matrix of transformation. I hope you got this video. If so, then please don't forget to like, share and subscribe my channel. And please check out Fuel Up Academy as well. Thank you so much for your love and support. Take care. Bye.